Hi, welcome back everyone. This is going to be episode 28. We're doing an existing programs tour, and this is going to be the existing programs tour number 2. So, put your seatbelts on, we're going to go for a ride, and we're going to be checking out all the programs that we've created since our last tour. And that was all the way back in episode 7. So here we are, episode 28. It's been 21 episodes since then. And let's check out what we have. We've made a lot of new games. So let's just go back in time, back to episode 8 and episode 14. We worked on Zelda. So I'm just going to go ahead and show you what that looked like. The problem with Zelda is it's really slow and it's really hard to manage the memory and all that. It's a little too difficult to make a practical Zelda game unless maybe we get rid of just a lot of programs. So I'm not sure, but we might move on from this game and just delete it or something, because this game is really hard to just get, and every time you reload a new screen it just takes a long time. There we go, it's loaded. I mean, it's not too bad. I mean, we could probably actually make like a game in this, but eventually it will just take so much memory. So it's kind of difficult to manage. It's fun to program. It's fun to think about what we could make in it and everything. But yeah, it's cool that we had the wall generation kind of created. But unless we can think of something kind of interesting to make out of it, it's consuming a lot of resources, and my calculator can only hold so much. So, yeah, Zelda was pretty fun. It was exciting. I wanted to see, an exciting game come out of this, but it really hasn't really ended up to something great yet. And we made a maze game since then, and I wanted to combine those two, but then recently I upgraded the maze game so that it scrolls, so that you don't even... So to combine that with this game would be kind of difficult, because now we have like a scrolling game and then we have this one, so I'd have to somehow extract the just the maze generation part of it and make, like, I guess one screen size mazes for some rooms or something. So we can put a little thought into that, but yeah, for now it seems like we can... Oh yeah, I forgot about the inventory screen. That's right, we even made an inventory screen. So yeah, this game was... It seemed so interesting at the time. And I kind of feel bad because I want to complete games and make them actually worthwhile. So if you guys could give me some ideas on maybe what we could do, if you understand kind of how that game was working and what the deal was with that. But for now, let's go ahead and move on to Lights Out, which I could only name it Light Out. Let's figure out what this is. So D, I forgot what D meant. Let's put 5. Oh, okay, so 5 would be how many times it's mixed. Right, so we go ahead and we try to guess where to hit all our lights, and boom, I think I got them all. Right? Yeah, I think I won. So I don't think there was a winning screen. I think... Oh, and see, if I press the green key, it tells me the solution. Right, so if I run this again, I could do like 20. So it really mixes up really good. And then when I get... if I ever get stuck somewhere and I don't know how to get rid of the lights, then there's a special thing for me to do there. See, it's like, I don't know how to get rid of these lights. It's too hard. So I press the green key and boom! Whoa! I gotta get rid of all those dots. It's a lot of dots to get rid of. But if I get rid of all of them, it tells me which ones need to be swapped. So then I can really easily find the solution. So remember, we put a hint key in. It's a very completed game, so this is likely to be deleted just because I don't have any more work to do on it. I could probably put like an end title or something like that, but But really, once a game is finished, it's just sitting there on my calculator, and it's not like I really play it or anything. It's to share with others, you know. But if I need the memory for making new games, then I'm gonna have to delete it. So this one I was planning on deleting. So at the end of this episode, actually, we're gonna go through, and I'm gonna have links to each of these programs, and I'm gonna scroll through them just to make sure that we don't miss anything, because I know I've uploaded the code to pastebin, but there's some bugs with that. There's some errors. So whenever I use ORs, like logical ORs, where is it? In here, these don't get copied correctly. So they don't even like exist when I upload my code. So I have to not only provide you the code through TI Connect, but I have to scroll through them and give you a video showing the code there. So that's going to be, I'm going to try to tag that onto the end of the episode. And speaking of tagging, that's actually another thing that I want to show you. Tag is another game that we've worked on, and it's another game that I believe is complete enough that we should maybe consider deleting it as well. So here we run around and the X chases us. So, and as soon as he touches us, then he runs away. And he's a Z, so now we have to chase him. Oh, the Z means that he recently touched us, so we can't tag, so that there's not a quick tag back. So now it's the X again, just to show that it's the same guy. And now we tagged him, now he runs away shortly, and then he chases us. So he doesn't try to tag us back too quickly. I remember that's why we have a Z there. No, get away from me. And we wrap the screen. So there we go. That's tag. It's a very simple game. Just the enemy chases us, and that's pretty much it. Let's go ahead and go to Snake. Now we have the old Snake, which is pretty much the same. Might as well just show you the new Snake. So we move around. We try to get all the dots. And I think that the double dots are like worth twice or something, or they make you longer. Can't remember how that works, but we move around. Dots appear, we consume them. No dots are appearing. Oh, dot appeared. And we wrap the screen, of course. It's a classic decision by Tim to always wrap the screen. Always wrap the screen. And when I work with matrices, I happen to always want to wrap matrices too. Just the way I think, I guess. I mean, it works. But anyway, what happens is we die, and then it tells us our length. And that was fun. So that, I'll probably delete it if I need the memory. So let's go ahead and check out matrices. Okay, so I did make a matrix solver. I can't remember if that was matrix or matrix 2. I think matrix is just where, yep, I guess I never deleted that. I should delete that. That's just where things like fall from the top of the screen. And that actually showed that back in episode 7, so that's been a while. So matrix solver, I think, I don't even remember what this does. I think it was solving, this was like a year and a half ago. I think it was solving some like QR factorization or something. One of those factorizations, or it's doing back substitution or something. That's all it was doing, and it kind of automatically did it for me. So it's not too interesting. You can just look those things up. It's just numbers, that's all. There's nothing more to it. It's just Google some linear algebra, some matrix decompositions, and you can go ahead and watch that old episode. But I don't have any matrices up in front of me to check the answer to see if it's correct. But all it does is I put in some numbers and it gives me back some numbers, and that's really all that's for. And then the next couple episodes after that, I worked on Zelda. I worked on Fall Down, and it looks like I need to go ahead and just recap fall down a little bit too. So here's fall down. I think I got it working. I think the stars represent where I should be able to fall. I must have been debugging it or something when I last played. But yeah, it looks like it's working okay. Feels a little slow, but doesn't seem too bad. Takes a while to load the next line. I think I'm printing everything out as one string, so that's why it can go so fast. But yeah, and then a very close upcoming episode, I'm planning on using the same printing trick to make something where we actually jump up, and we'll see how that works. But yeah, it seems like fun. I don't know what happened. Let's just die and see what happens, because I'm sure it's supposed to slowly speed up or something, but I don't know if I have the settings set to do that right now. Seems to be taking a while. Okay, so this game was pretty much finished. I mean, I want to delete it. I want to save the code. Looks like it just exits. So let's go ahead and check out Car Puzzle. And we have some recursion in here. This program I never actually finished. I should probably try to come back to it. Although it seems like it's going to be tricky. It's going to take some computation. So basically it's that car slider puzzle that you've played probably online or something before. And you figure out the puzzle to get the car or the box or whatever to exit out one little hole in the side of the screen, but you got to move all the other ones out of the way first. So just to get that working and to generate a proper puzzle seemed kind of difficult. So we were kind of in middle of that. We never actually finished it, but I'm not going to delete it just in case I try to go back and actually finish it. So let's go ahead and go to chess, which is what we worked on after that. And I made 4 episodes of this, just straight in a row. Basically, you can select a pawn, kind of move him where he needs to go, and then you can't move him anymore because it's plus's turn. So their minus went. Minus, I guess, is the whites, and then the pluses are the blacks. So it shows you how many moves you can move. See, I can move up there, and then I can say, no, I don't want to move him. And I can select a different pawn. Or I should be able to unselect him. Oh, I guess all I have to do is press the green button and it unselects him. Okay, so there we go. Let's see if we can do some battle here. So I'm going to move this pawn up a little bit. Then I'm going to take this plus pawn. I'm going to move him up. Then I'm going to go back to this pawn. And now it looks like I can kill that pawn. I can take him. And there we go. I took his pawn. So there we go. Can't remember if I think it checks for checkmate and all that, which is kind of crazy. But it's kind of built in already to check how many moves each piece has. So when it checks for checkmate, it just makes sure that the king's in check, and then it makes sure that there's no moves that prevent that, I guess. And that was pretty tricky. Took a lot of code, I think, to do that, and I definitely want to save the code for this one so that everyone can use it. But yeah, that's chess, and we're gonna scroll through just to make sure that we don't miss anything, just to make sure that if there's any bugs, like if there's any logical ors that don't get copied over, at least we've scrolled through it and we can double check our copies to make sure that we copied the program correctly. So that's chess. And now, recently, we got Maze, which is pretty wonderful. I think I need to generate a new one, because running all those other programs probably deleted Matrix B, which is something that we need. This one generates a huge matrix, so it takes up a lot of memory. So it's a very recent program, so I don't think I'm planning on deleting it yet, but in the future, I probably will have to consider deleting it because it just consumes a lot of memory when it's run. And if I can't run it, like if I don't have the memory space to run it, then there's no use in just keeping it around, so I would just delete the program as well. But it's definitely going to be saved somewhere. I'm going to try to save the code on pastebin and then take a video of scrolling through. Here we have our little loading screen. That just gives us our that shows how much of the actual maze set generation is being processed, because we have to go through and check everything and combine sets together, which we do in a fairly slow way. But I guess we can just wait it through. So here it's checking through every single wall, and that is the percentage showing how many walls have currently been checked. And once all of them have been checked, all 100% of them, then it moves on to doing whatever else it needs to do to prepare the maze for us. So the main part is done. We still got to wait a little bit more just to maybe where it's putting the dots around or something. And once it's complete, then we'll be able to play on the maze. So I'm showing this one because I actually started this before I started the Towers of Hanoi. So the last program I'm going to show you guys from our list of episodes since the existing programs tour number 1 is the Towers of Hanoi, which I'm going to show right after this. So here we go. It automatically centered us correctly, so we were kind of too far off, but it kind of moved us, which is great. And then now I can go around and I can get these dots. And if I did it correctly, we should be able to consume the dot even if it was at the 1-1 coordinate of the maze. So I think I fixed that bug because it crashed when I wasn't recording last time, when I didn't feel like fixing it, and then I chose to fix it. So here we go. We can consume these dots, and then this maze basically just wraps around, but it also always keeps us centered even though it wraps, which is really cool. I really like that. I actually made a program in Java many years ago that basically did the same thing. It always kept you centered, but it also wrapped the map as well. So it wrapped the screen and it wrapped the map. So here we go. We can keep just finding these dots, and probably don't need to consume all of them. So let's just see if we can at least find all of them. So here's one. I'm not going to get that one that goes up. And I'm not going to get that one that goes down. And I'm not going to get that one, but we can see that we could get it. So here we go. Go up and left. So eventually we can figure out, we can search the whole maze, and everywhere that you see, we can reach. So even if it's way out here to the right, we can actually reach that by going probably to the right. So we can go left by going right because it's all wrapped on the sides. It's all the same maze, and it's all connected too. So here we go. If we keep going right, it works kind of like the world does. You reach the east by going west, and there we go. We found it again. So that was really fun. It took a lot of work though, a lot of debugging to figure out where. After I got a lot of work done, I had to figure out what I got wrong, and silly me forgot to add a K somewhere, and that wasted probably like an hour and a half, even though it only took me like half an hour to write the code. So 99% of the code, and then took me 99% of the time took me to write the last like 10% of the code, the last 1%. Well, more like 90% of the time, I don't know. Anyway, well, it was like 75% of the time to write like 1% of the code. But yeah, that was fun, kind of. Except for the debugging part, that was actually fun. And the end result's really beautiful. I really like this. And I love how it's fast because I'm using the strings. Or actually, I'm just using one string here to print it like this. So that's the maze game. And then Towers of Hanoi, what I like about this is it's actually not too hard to code. So I'm going to show you the one that we didn't do for the episode. We just, actually, let's delete this because I don't need that. And let's delete this. And let's delete this. And yeah, we don't need this stuff up here. Anyway, okay, so Towers of Hanoi. The original one, let's do level 8. Okay, so the original one, I could select these, I can move them around. Say, okay, one's on top of the 2, 3's over here, the 1's over here, and the 2's over here. So I showed that to you guys, even in the last Programs Tour, I believe. So, yeah, that's an interesting game. But then I actually made an episode recently, and it's Hanoi 2. And the computer solves it for us. And there we go. We got a calculator that solves Towers of Hanoi completely for us. And it actually uses recursion here, which is cool. Because it's kind of hard to do recursion on the calculator, but we can still do it. And there we go. Solved it. So there we go. That's all the programs since episode 7.